it never ceases to amaze me how throughout history humans have just looked up at the sky and wanted to, figure it all out. And some folks really dedicated their lives to that pursuit.
Right.
Yeah, and today we're going to dive deep into one of those remarkable figures,
Right.
Battani, a ninth and 10th century Arab astronomer and mathematician. And get this, he was working in what we now call Turkey and Syria.
Wow.
So yeah, we're going back in time. And for this deep dive, we really want to uncover just how significant his work was. And I think you'll be surprised by how accurate he was and how much of an impact his work had, lasting impact, even on us today.
Mm.
Yeah, so we've got sources detailing his life and some of his scientific discoveries. You ready to jump in?
Let's do it.
Okay. So one thing that really struck me was just how accurate Battani was, especially when you consider, he didn't have access to all the fancy tech we have now.
Oh, yeah, for sure.
I mean, think about it. He calculated the solar year. That's the time it takes for the Earth to orbit the sun, right? And he was off by like minutes from the modern value.
That's incredible.
I know. I mean, can you imagine trying to track something that vast, the Earth's entire orbit without telescopes and computers and all that?
It's mind-boggling.
Right. Talk about dedication. And it's not just that one calculation. He also made a lot of improvements to the existing astronomical tables. And those tables actually ended up being really important for European astronomers centuries later, like during the Renaissance.
Oh, so his work really had some legs.
Totally. It's amazing to see those connections across time. Right. Oh, and he also figured out the tilt of the Earth's axis and studied the motions of the sun and the moon, like in detail.
Yeah, I mean, that was a big deal back then. These were cutting-edge questions.
For sure. And here's the thing. He wasn't just taking what earlier astronomers had said and running with it. He was looking at their work, like Ptolemy's work, and critically evaluating it, and even correcting it, particularly when it came to how the sun moves.
Right, he was challenging the status quo.
Yeah, exactly. And that's what moves science forward, right? It's not just accepting things at face value. It's about questioning, refining, and building on what came before.
Absolutely.
Okay, but wait. There's more.
Oh.
Yeah. He didn't just look at the sky. Battani also changed how astronomers actually did their calculations.
Okay, how so?
So get this. He introduced and started using trigonometric functions.
Trig.
Yeah, like sine, cosine, tangent. Before him, people were using like geometric methods, but he brought in this whole new mathematical tool set. It's like a total shift in thinking, a different way of approaching these problems.
A game changer for sure.
Huge. And here's something else that blew my mind. This wasn't just some isolated thing that happened over there and then disappeared,
Okay.
His use of trigonometry and the relationships and identities he developed, they actually influenced mathematicians way beyond his own time and place.
Really?
Yeah. In the Islamic world and later in Europe, too. Shows you how knowledge can really travel and have this like ripple effect across cultures and centuries. I know, right. Okay, so just to give you a little more context about the man himself. His full name, and I'm going to try to say this right, was Abu Abdullah Muhammad ibn Jabir ibn Sinan al-Raqi al-Harani al-Sabi al-Battani.
Oh, wow.
I know, right? A mouthful. But what's interesting is that he came from this Sabian religious community, and he was definitely influenced by Greek thinkers, but he was also like forging his own path, making his own observations.
Sounds like a true pioneer.
Right. And his most famous work, his book, it's called Kitab al-Zi, which means the Book of Astronomical Tables, and it got translated into Latin in the 12th century, and that's actually a really big deal because it meant that European scholars had access to his work. They were using his tables, as a primary reference for centuries.
Wow, so his impact was huge.
Huge. And actually, Copernicus and Kepler, they were both influenced by his work. That's a pretty impressive lineage. So, I mean, when you think about all that Battani accomplished, it's incredible. Really accurate astronomical calculations, a complete shift in how these calculations were done with the introduction of trigonometry, and then this lasting impact that influenced Western science for like hundreds of years. It's remarkable how much he figured out without all the technology we have today.
Yeah, it really makes you think, about how our understanding of the universe keeps evolving.
Mm-hmm.
Like how many things that we take as fact today will be viewed totally differently by, future generations. Just like Battani built upon and even corrected what people thought before him. Who knows what new discoveries will come along and change everything again.
Oh, yeah. I mean, who knows what we've got wrong?
Exactly. It's humbling, really.
Totally.
The universe is full of surprises.
So true.
And who knows what we'll uncover next.
That's the beauty of it, right? There's always something new to learn.
Always.
Well, on that note, I think we're going to wrap things up here for today's deep dive.
Okay.
Thanks for joining us. And keep looking up.
Yeah, keep wondering.